As a second example of our kinematic assumption, let's consider the case of a beam bent around a cylinder. So I have a large rigid cylinder of radius r, and I've clamped a beam at the top of the cylinder, and I'm bending the beam down around the cylinder. So the cylinder radius is large in this case. And I'd like to determine what the bending strains are in the region where the beam contacts the rigid cylinder. So I have this contact region here where the beam is in contact with the cylinder, and I'd like to determine what the bending strains are there. But in the contact region, I actually know what the curvature is of the beam, because the beam conforms to the rigid cylinder as it bends around the cylinder. And so just from straight geometry, I know that the curvature in the contact region is 1 over the radius of the cylinder. So I have, quite trivially then, that the bending strains are just equal to minus yr. So y is, again, the coordinate in the vertical direction of the beam, and so x again is always our axial coordinate, and z is the coordinate coming out of the plane when we draw the beam.